Hello, class. My name is John Adamson, and for my advanced energy presentation, I will be talking about the anaerobic co-digestion of wastewater, a process that is added onto already existing wastewater treatment plants in an effort to make them more self-sufficient and take advantage of present human consumption and refuse in a way that creates some renewable energy. So without further ado, let's get into it. So, at the crux of this whole process is the sewage sludge that is created from the wastewater treatment plants. This sludge is filled with microorganisms, bacteria, that do a process known as anaerobic digestion. So what happens in anaerobic digestion is that these microorganisms break down organic materials from the wastewater. All the nutrients and all the stuff is gone through us and come back out. And after doing digestion, they release methane, much like cows produce methane through their own digestive processes. So where the co-digestion comes in is that other liquid wastes, like restaurant grease, airplane de-icing fluid, and sour milk, are combined into this wastewater sludge. So it's not just what came from the sewers, but waste that came from other components, mostly organic waste, that can then be combined into this mixture to create an even or more organically rich, nutrient-rich compound, right? And this resulting mixture, when the microorganisms get to it, they digest so much that it creates a methane-rich biogas, which is then burned to create heat and electricity, right? And this heat and electricity can be used within the plant and also to facilities around it, maybe in the city, other places, depending on the production. So again, like I said, the focus is to make these places a lot more self-sufficient. So on our next slide, we have a pre-feed sequence tank. This is from the Hermitage Municipal. It's the municipality. I'm going to go talk about this later. It's a great example of how this technology has been implemented. But here's one of those tanks where the mixture of the sewage and the other organic fluids are kind of mixed together and sit and rest. As you can tell, there's kind of like a ballooning part at the top of the screen. And that is obviously a representation of some of that gas that's being happened. The waste then goes from this tank, and it goes into the digesters, which I will explain further in the next slide. So here in this next slide, as you can see, there is the substrates, which are the sewage sludge, and then the co-substrates, which are food waste, and then dairy waste, etc. So then it goes into this digester, right? It's fed from these tanks through the tubes into this digester. And that's where it's heated up, and you get the sludge and the gas are kind of separated, right? So you have the gases, the sludge is heated and the gas is burned, and then you end up with the biogas, which is sent to another place to be made into heat, or it's sent to another place to be made into electricity, and the remaining heat is funneled often back into the system itself to continue heating up the sludge in order to produce more heat and electricity. So as you can see, there's already kind of this like self-feeding loop that's occurring, in this process. And then the other part of the waste that is also processed is digestate dewatering. So, not although the sludge and the mixture turn into they produce biogas, there's still a lot of it left over that is still very much sludge. So this reuse is then used, dewatered, dehydrated, basically, to extract water and to leave kind of like this nutrient-rich biosolid behind. So you not only do you have the electricity and all that stuff, but you also have the water, which is then reprocessed through the wastewater plant, which is conveniently located right there, and you have this biosolid. So that plays into some of the advantages we have. So the process of burning creates carbon dioxide gas, which is cleaner than the methane gas produced in anaerobic digestion, right? So this methane gas, which, as we covered in class, is very harmful to the environment. When it's burned, there is carbon dioxide gas that is created. So effectively, we're turning this, this terribly, this harmful methane gas into carbon dioxide gas, which is while it's not great for the environment in massive quantities, it is better. So we're lessening this impact. And then it helps mitigate the effects of the illegal dumping of liquid waste like restaurant grease into the sewer system, because then the city does not have to go in and repair the sewer system from things that are not supposed to go in there. So they can decide what they want to add to the sewage sludge later, and then pre-treat it and whatnot. But when you have these, people pouring these substances that aren't supposed to go in the sewers into the sewers, it creates a lot of problems, like gunking up. The sewers get gunked up, or parts of it get damaged, and that eventually costs the city a ton of money in repairs. It also reduces the energy consumption of the plant by supplementing electrical needs by roughly 50%, although in some cases, depending on the size, it can be even more. So it's not yet able to completely make it independent, but it is, again, massively helpful to maintaining the cost of running the plant. And then this also because it reduces waste, it reduces costs for the city at landfills, which is where these liquid waste typically end up. Believe it or not, it does cost money to throw trash away at these big landfills. So the city not only saves money from repairs, but also from dumping trash, and then the process kind of runs itself. So because of that, it's self-sufficient, and it's easy to manipulate by the operators, who can then just control a couple things instead of having to put a whole operation together. So I was talking about this a bit before. Biosolids that are produced can be used as a fertilizer. This remaining sludge, which is dehydrated, creates this nutrient-rich biosolid. And then this biosolid is often sold or distributed by the cities to farmers for fertilizers, right? So what's often happens with like horse manure or cow manure and all that stuff can be used with human waste. And there are, it's not a perfect science yet. There is some concerns, but the anaerobic digestion process helps fight off some of these concerns, because it's not just biosolids from wastewater treatment, which is what it usually happens. It's gone through this entire other process where things have been broken down by the microorganisms, and then a whole bunch of other stuff that happened to it. It's been retreated, so it helps mitigate some concerns about pollution that might come from normal just normal wastewater. So speaking of that, we can go into some of the barriers of this program, of this process. The wastewater created as a byproduct of the process is carbon dioxide rich, and contains depleted levels of oxygen. If this is directly released into watercourses, which often happens with wastewater treatment plants, it causes eutrophication, which I will get into a bit more later, because it is kind of a more complex process. But it also is less efficient than gasification, which is the conversion of organic-based carbonaceous materials at high temperatures without combustion, right? So gasification, you are just heating things up rather than burning them. And you get a higher yield of the energy, the heat and electricity back through gasification than you would through the combustion process of anaerobic co-digestion. And then it requires spending for the necessary equipment. I'm going to talk about an example later in a city that implemented it with Hermitage, and it cost them $32 million startup costs. So that can be off-putting to cities that want to implement this, because you have to turn that kind of money up front, and potential yields won't be seen until the future. And then these can create a strong odor if run inefficiently, and that can raise concerns among citizens, because no one wants to live next to a bunch of burning human waste, potentially. So eutrophication causes these dense algal blooms that disrupt the food chain and are deadly to animal life, because they block out a lot of the nutrients and sun needed in everyday life. It completely modifies environments like overnight. So more treatment of the waste, such as membrane filtration or aerobic treatment, is necessary to correct said effects of this process. Otherwise, you're dumping this untreated, nasty water that creates massive effects to the ecosystem. So this is from Anaerobic, and here's even more from Anaerobic. Here you can see where the nutrient intake comes in, and then how the algal bloom kind of blocks and absorbs all these nutrients that are coming in, and it's creating like this very thick top layer, full of like carbon dioxide and everything, and that reduces oxygen content at the bottom, because all this carbon dioxide is entering this area, because that's what plants do. Plants take in carbon dioxide, so it's creating this imbalance within the environment, and then you see that poor little dead fish over there. So we can talk about implementation. Anaerobic co-digestion has already been implemented in different places around the world, such as Vancouver, Australia, and the San Francisco Bay Area. It will continue to grow because, like you said, you just have to add it onto these wastewater treatment plants, and it deals with a major part of urban municipal waste, even the largest, which is, human waste. And there's work that can be done to make this more efficient, which will make it more attractive to people in the future, such as improving fuel cells and adding pretreatments to the waste. So quickly talk about one of the implementations. There's this small town, medium-sized town in Pennsylvania called Hermitage, and they decided to add a biogas facility to their wastewater treatment plant because they wanted to be more environmentally friendly and they'd heard about it. So the plant was working. The plant was so successful, and it was able to implement liquid waste. So it was originally just anaerobic digestion, but then they added this co-digestion component where they added bottles of milk from schools, hospitals, and this local dairy company that had to, with all their leftover milk, they had to take it across state lines and pay to get it dumped and everything. So it was a big, inefficient process. So instead of that, they could just take it to this plant, and there they had this machine that would puncture the bottles, and all the liquid would come out and then get mixed with the wastewater. So this process allowed the city and then also the dairy company it worked with from sending 15,000 gallons of waste to landfills each week, which it may not sound like a lot, maybe, but that is a tremendous amount of waste, especially when you think about it in a year. And then not only that, but because of its self-efficiency, the monthly electrical bill for the wastewater plant was $25,000 between $25,000 and $28,000 before adding this plant, and it reduced to only $3,000 after adding this process. And then finally, that plastic waste from that leftover milk that we were talking about earlier, the punctured bottles that all the liquid waste went through to go into this mixture, the plastic was recycled rather than sent to landfills, which further reduced the costs of landfill costs. So instead of on top of those 15,000 gallons of waste, you also have this plastic that's not going in landfills and instead being reused and recycled. And that is the end of my presentation. Here are my references. I have those and those. Thank you so much for listening. And yeah, I think this is a very promising technology, and I'd like to see it implemented in a wider scale in the future. I think it's a very easy fix and something that should be everywhere. So yeah, thank you again. Bye.